fires are to be controlled or extinguished, the department must pre-plan and be capable of skillful execution. Trained officers are essential. Modern equipment is necessary. But in most cases, the person who actually controls the fire is a key man, the nozzleman. In firefighting, know-how is vital. There is no substitute for an understanding of fire behavior and an understanding of your equipment. You must be able to focus this know-how on fire conditions as you find them if you are to be a top-notch nozzleman. Let's start with your chief weapon, the nozzle. It's important to use the right tools for the job. The smooth bore of the solid stream nozzle delivers a solid, high-velocity stream. This gives you a long reach and delivers a large volume of water. Both the solid stream nozzle and newer adjustable nozzles have a ball-type shutoff. It has nothing to do with the shape or pattern of the stream. The pattern is controlled by the forward part of the nozzle. Today, the most versatile nozzle is the adjustable type. It can deliver patterns ranging from a wide-angle stream with low velocity to a straight stream with a high velocity. As a nozzleman, you should have an idea of the mechanics of its operation. With new constant gallonage nozzles, your flow in gallons per minute is the same in all positions. These nozzles are designed to operate at about 100 pounds nozzle pressure. Most nozzles have marks or notches which serve as a guide to indicate the degree of fog. These are helpful, but when you're fighting a fire, the important thing is not which mark you're on, but whether the fog pattern you are using is correct for the job. To choose the right pattern in each situation, you must be familiar with fire behavior. This fire could go through several phases. Most fires start with a small flame which may continue to spread over the fuel surface. As the heat builds up, there will be a flashover, and if air is available through windows, doors, or other openings, the fire will assume a steady state. In most cases, this steady state will expand only if more air is made available. Additional doors may be opened, or the fire may go on to burn through the walls or ceilings, and eventually it will no longer be confined. Because so many structure fires are of necessity attacked during the steady state, we're going to deal primarily with fires of this nature. The temperature of the fire we have described will be in the neighborhood of 1400 degrees at ceiling level. You'll need as much protection from that heat as you can get. When your line is charged, you will adjust your fog pattern to protect you from the heat, but you can and should improve the effectiveness of your protective clothing by wetting down. Protective clothing does an excellent job of shielding you from falling debris and heat. As a nozzleman, you should know the three methods of attack. If the fire is small and heat accumulation is low, you will probably make a direct attack with a relatively straight stream. Intense heat may force you to use either the indirect or the combination attack. With the indirect attack, you spray only the heated overhead. The combination attack, a combination of the direct and indirect methods, is accomplished by rapidly rotating the nozzle in a clockwise direction following the perimeter of the room. How do you choose between the combination attack and the indirect attack on the fire ground? If only one or two rooms are involved and one line will give sufficient flow, the combination method will give the fastest results with a minimum amount of water. This method cools the atmosphere and the heated materials at the same time. Consequently, large volumes of steam are generated and the fire is blacked out quickly. As compared with the combination method, the indirect attack continues steam production over a somewhat longer period of time. This can be used to advantage in a complex situation where several lines are necessary and their coordination is a problem. In any attack, the maximum heat absorption of water is utilized only when the water is converted to steam. Don't confuse an indirect attack on a fire with indirect results. Fire may follow various channels in spreading from one room to another area. Steam generated by either an indirect or a combination attack may follow the same channels and control the fire. This is a valuable indirect result. As a nozzleman, you need to know something about thermal balance, what it is and how it can help you. Almost every fireman has approached a fire which he could see clearly, but just as soon as his fog pattern hit the interior of the room, smoke and steam swirled down and his visibility was gone. What happened? The hot air, smoke, and gases are lighter than cold air. In an undisturbed situation, these products of combustion will be evenly distributed at the top, and the cooler, fresher air will be at the bottom. The atmosphere in this room is in thermal balance. Just as soon as your fog hits the heated gases near you, they cool. The cooled gases drop, and thermal balance is upset. This causes circulation of fire gases and smoke, which limits both visibility and entry. The thermal balance which most fire situations establish will not be upset if the correct nozzle pattern is used.